This video is on mutually inclusive and exclusive probability. We're going to be dealing with mutually exclusive and inclusive events. The first one we're going to talk about is mutually exclusive events. Mutually exclusive events is when they are exclusive, that means that they cannot overlap each other. Exclusive means that there is no overlap. There's no overlap. So suppose you have a bag of 3 red marbles, 5 blue marbles, and 7 green marbles. So we have red, blue, and green. What's the probability that you select a blue or a red marble? Okay. So the question is, can these both occur at the same time? The answer to that would be no. These cannot happen at the same time. Why not? We want to select a blue or a red marble. We cannot select a blue and a red marble if we're only drawing one marble. We're drawing one marble, so we can either draw a red one or we can draw a blue marble. That's it. So there's only one marble. We're only drawing one marble, which means that we can only draw one color. So mutually exclusive events are also called disjoint events. That goes back to before when there is no overlap. Disjoint events means there is no overlap. This is when you have one event, so one draw, one event where two or more outcomes cannot happen at the same time. So the outcomes were a blue and also a red marble. So it's when we're dealing with one event, we cannot have an and. One event has to be an or. So if it is an and, that would be an overlap, and we would have to be very careful with it. That would be the mutually inclusive. They are included together. So the probability of two mutually exclusive events occurring at the same time has to be 0. They have to be exclusive from each other. They have to be separate from each other, and so therefore they cannot happen at the same time. So in order to find the probability of one or two mutually exclusive events occurring, we're going to use the following formula. It's just an OR problem, so it's the probability of A union the probability of B minus the probability of A intersect B. But in this case there will not be an intersection at all because they're mutually exclusive. So this part will just be 0 because that's them happening. That probability will be 0. So all you really have to do is just add the probability of A and the probability of B. You just have to add the two probabilities because you would just subtract the overlap, which in this case the overlap has to be 0 for mutually exclusive because they cannot happen at the same time. So we're going to do 2 examples of this. So if you choose one of the integers 1 through 10, what is the probability of choosing either an odd or an even number? So the question is, one question is, are these mutually exclusive events? Why or why not? Exclusive, meaning that there is no overlap. Is there an overlap between odd and even numbers? There is no overlap. That means that these are exclusive. So yes, these are exclusive because even and odd numbers can't happen at the same time. So even and odd numbers can't happen at the same time. So anytime you see an OR problem, you're going to add the two probabilities, then you're going to subtract the overlap. And in this case, there cannot be an overlap because these are mutually exclusive. So that's great. So we just add the two probabilities. So we're going to complete the following statement. We're going to do the probability of odd or even is the same thing as the probability of odd plus the probability of the evens. So if we're going to fill them in with numbers, let's actually make sure we know what numbers we're dealing with. We're going from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want the odd numbers. So I'm going to use highlighter for my odd numbers. I'm going to use a yellow highlighter. So all my odd numbers I'm going to highlight. I'm going to highlight 1, 3, 5, 7, and 9. And then for all my even numbers, I'm actually going to circle them in pink. So 2, 4, 6, 8, and 10. None of my yellow highlight and my pink touch each other. I don't have yellow and pink on the same number. Therefore, that's how you can automatically tell that these are mutually exclusive, because they are all separate. So what's the probability of odd or even? So how many odds do we have? We have 1, 2, 3, 4, 5. There are 5 yellows out of how many numbers total? There are 10 numbers, so it's 5 out of 10. Then we want the probability of even. So again, there are this pink circle, 1, 2, 3, 4, 5 of them out of 10 numbers total. So that's 5 circled out of 10 total. That would be 5 out of 10 plus 5 out of 10 is 10 out of 10, which equals to 1. Now, does this answer actually make sense? That the probability of us selecting an odd number or an even number is 1. That there's a 100% chance of us picking one of those numbers. There are only odd and even numbers between 1 and 10. So that means all integers, because it's an integer. All integers, all natural integers, have to be odd or even. So this answer has to make sense. So yes, there are only odd and even numbers, or even integers, between 1 through 10. There are only odd and even integers, because it's not talking about decimals. It's not talking about negatives. So that makes sense that we would have a 100% chance of us picking an odd or an even number. This next one is 2 fair dice are rolled. So that's telling us that we have 2 dice, but it's only rolling 1 time. So we have 2 dice in our hand and we're rolling them. Okay? We're not doing two rolls. We're doing 1 roll. What's the probability of getting a sum less than 7 or a sum equal to 10? Are these events mutually exclusive? So let's actually draw this out. So with 2 dice problems, using a grid of outcomes is useful. What we do is there are a possibility of getting a 1, 2, 3, 4, 5, or 6 on our first die. And then we also have a 1, 2, 3, 4, 5, or 6 on our second die. Now, we can only, when we roll these die, we would add these numbers up to see how much we get. So we're going to add them. So to get if we roll a 1 and a 1, we would add up to 2. A 2 and a 1, we would add up to 3. Then 4, 5, 6, 7. If we rolled a 1 and a 2, we would get 3. Then 4, 5, 6, 7, 8. We keep going with this. This would be 4, 5, 6, 7, 8, 9. This would be 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, and 12. The highest number you can get when you're rolling 2 dice is a 12. The lowest you can get is a 2. So let's make sure we understand what we're trying to do here. We want a sum less than 7, so I'm going to highlight that in yellow. So sum less than 7. So a 2, the 3s, the 4s, the 5s, and the 6s. These are all less than 7. Then it says, or a sum equal to 10. So I'm going to circle that in pink. So all the 10s. Now, none of these overlap, so that would mean that they are mutually exclusive. These are mutually exclusive. These are mutually exclusive because there is no overlap. So again, anytime you see the word or means we're going to add, but then subtract the overlap. And because these are mutually exclusive, there is no overlap. So all we have to do is just add the numbers. So we want the probability of getting a sum less than 7 or a sum of 10. So the individuals, so again, or means we're going to add and subtract the overlap. So let's look at the first one. Sum less than 7. How many numbers did we highlight in yellow? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this first one is 15 out of. There are 6 by 6. There are 36 numbers possible that we could have rolled. We're going to add, because it's an or. We want the sum of 10. There were 1, 2, 3 out of them total, out of 36. And there was no overlap, so we would subtract 0 out of 36. We'd subtract 0. So really, that part's gone. We just do 15 out of 36 plus 3 out of 36, which gives us 18 out of 36, which is 0.500, 3 significant figures. We have half a chance, or 50% chance, of getting a sum less than 7 or a sum of 10. Those are mutually exclusive events because there is no overlap. So when you subtract, you would subtract nothing from the addition.